All right, guys. It's 2 o'clock. We're going to get started. Okay, so we are on week 4 of the semester, as you know. I remind you, week 6 is exam 1. So make sure you're studying for that. So today, this week, we started one of the most important topics, which is the perceptron. So I went over the code, right? So I've given you the Python code for that. We built the perceptron from scratch in NumPy, right? And today, I have a couple of things that I'm going to cover. One of them is, we have this learning rule in the perceptron that I just wrote in there, and I said, trust me. So today we're going to do the derivation of it to see where that's coming from. It's some math, but it's logical, and it's going to give you a lot of intuition as to where those things come. Okay, so that's one of the things I want to do. And then the other thing is the homework, as I said, new homework assignment. So you have currently the WECA homework, right? Make sure you're submitting, all of you are submitting that. That's due by Sunday, I think, the last day it closes, correct? Check right space. But please make sure, I'll give you some time today. I don't think this will take the whole period today, so at least 20, 30 minutes. You guys can ask questions and things like that, all right? So today, as I said, we're going to do the derivation. So we are, we've done this, machine learning pipeline, feature engineering, all of this has been covered. WECA, that's been covered. KNN, you already know one algorithm, right? How that works. Make sure that you understand it really well. And then we are currently in the perceptron. And the perceptron is down here for some. Okay, so let me move that up. So I'm going to move perceptron. We're covering some of the classical algorithms, KNN, perceptron, hot-field networks, and a multi-layer perceptron, all from scratch. And all the key ideas, they're all related, actually, so it's really good. So here is the perceptron. This, if I click on this, it takes us. Okay, so let me modify this link. It should take you here. So let's go to the edit the link. I'm just going to change this. Takes you to neural nets. So they should take you now to the perceptron. All right, so good. Okay, so let's take a look. So WECA, KNN, and now the perceptron. Right, so it takes you to the content. So if you know, as you know, the code that I worked on Monday is this one, right? So that's the script. Today I'll just touch on it a little bit more, but we were done with it. We were able to measure performance, and I have, we'll pick up from there. There's all the information. Read it. Some of it, it's just historical, right? And some notable papers. If you're curious and want to see the original papers, you can. All right. So let's go back. Perceptron. All right, so I will come back to the perceptron in a second and just do the derivation of that learning rule, right? And where that came from. We were motivating the problem of that device, right? We had that device, right? And we know that it had some inputs and it was trying to predict if the voltage was over 0 or below 0, for instance. But we have to tweak all these knobs, right? And these knobs are really the weights that you have to learn. And that's where the algorithm comes in. And it's been a history of that. It's been a history of creating the perfect algorithm to learn those knobs, because obviously as the models get bigger, you have way more knobs, right? So we'll pick up from there. So today, the first thing I want to do is assign the new homework assignment, give you the new homework. So let's go to table of contents. So I changed the homework this semester. Last semester, I did this one, KNN mini project, and essentially it's the same thing, deploy to the web with PyScript, but the difference is last year I asked students to do KNN, right? And so they did KNN on the web. This semester, I'm changing it to the Perceptron instead, right? And that's the only difference. So I'll provide the information for this today. Okay, so here is kind of the description of what I asked last semester, and I'll just modify this a little bit. Obviously, it'll say instead of KNN mini project, it'll say Perceptron. Using KNN and PyScript, develop a generative model. Your goal is to generate images based on conditions in your own data set. So that was the problem. You need to annotate your own data set. You need to deploy the web via GitHub. So that's what I'm going to show you today, how you can deploy a website, a little website on GitHub, get something called GitHub Pages, and that should be pretty straightforward. And then I'll provide some links, of course, of how to actually implement this. And you will see it's actually not very difficult. All right, so I have a link here. Back to table of contents. So I'll be modifying that. This will say, as I said, Perceptron. So let's click on this link. And this is the homework that I provided last semester. But now I'm going to do a new one. So it'll be under homework here. As you can see, this is the last year. So I'm going to do this one this semester. And remember, you are building this device here. Okay. So what I need to provide is some examples of how to do this, right? So I'm going to do that now. So as I said, it'll link to this. Okay. Click, it'll bring you here. And it'll say, okay, what you're building is this device, but you're building it on the web. You can do it however you want, as long as the logic is there. If you want to take pictures of this and put them on the website, that's great. Or not, or you don't have to. All right, so what I do need to provide is PyScript. So let's talk about that one. And you'll see it's actually really straightforward. So in this class, I like to show you guys not just the algorithms, but also ways of deploying your models, right? What's the point of building models if they only run on your Jupyter notebook, right? You know, what's the fun of that? So I use two methods. One is called PyScript. And then when we learn Torch, we're going to look at something called Onyx. And both of these allow you to take a model, right, and make it available in a website so that then you can, from anywhere in the world, you can do some simple machine learning, right? That is in that. And remember, we are limited, if you're using GitHub, to 25 megabytes per file. That's if you're using the free account. So that obviously is going to be a constraint. All right, so that, but anyway, so in this folder here, you see called deploy to web. That's usually where I keep all examples of deploying things to the web. And I provide all the links here. So in the past, for instance, with Onyx, students have done things like this. They click on browse, grab an image or something, classify it. You know what I mean? Is it a cat or a dog? Other students have built, things like this, very simple. You enter some values, click run, boom, it predicts a class for it. So that's another one. Using a camera, you can nicely... Well, I can't use my camera because I'm obviously using it for this, but you can start a webcam, do things, and it classifies it in real time. That's a fun project. You can use XGBoost also, so you can use either the Onyx approach or the PyScript approach, which I'm going to show you. The nice thing about the PyScript approach is it allows you to write Python code like right there. Okay. All right, so this is actually the example that we're going to be using. So please make a note, since I provided a lot of examples here for this particular homework assignment. This is what this link here that I'm highlighting is the example, okay? I went through this one yesterday. PyScript updated, so be aware of that. Like I just updated. So some of the syntax has changed. So if you find some old examples, it may not run, right? So I've updated my example to use the new PyScript. Okay. And like I said, all of you have taken 110. That's really all you need. Okay. And then all the coding will be done in Python essentially. So I'm going to add this link to the homework. Okay. So I grab that one. So I'm going to go to homeworks here, web perceptron, which is the homework you're building. And I'm just going to add in here examples of PyScript. Say so. PyScript sample. There it is. Okay. Everyone with me? The changes. All right, there you go. So now if you click on this, it takes you to the examples, and then this is the example that we're going to use. I'm also going to provide the PyScript website, as it's really nice. And if you're curious about it, I encourage you to take a look at it. It's this one here. And you can go to examples. Right, and it's got all these examples of how the code works, but I provided one example myself. That should be more than enough for you to play with it. So it's got some nice, like, what is it? You can do anti-gravity. I thought this one was nice. See, it's create animations and things like that. It's all in Python and HTML, and it runs on the web, essentially, right? So it's like JavaScript a little bit, only allows you to do Python. And obviously, I'm not using this for games in this class, but for deploying some of the machine learning algorithms that are pure Python code. NumPy will run here. Pandas will run here. So all the great libraries, okay? So I will provide this link also so that you guys, in case you are curious about the syntax, you can take a look at it. Provide that there just below the actual example that I want you to use. All right, so that's what I'm going to talk about next. So you guys know how to run some Python code in Anaconda. We've done two algorithms at this point, KNN, and now the Perceptron, right? And you've seen the basic flow of that and how we run that code on a Jupyter notebook. So now what you're going to learn is how would you take that code and deploy it into a website? And it's actually very straightforward. There's just a few tricks that you have to take a look at. All right, so for that, I've created an example. Let me close all these. All right, so we're back here. Bright space. Click on the link. Change this, as I said, to the homework web perceptron, PyScript examples. And this is our example. So we're going to go this, if I click on this, it'll open the actual website. Okay, it'll open the website and run it. But we also need to go to the repo on GitHub. So that's what I'm going to do. I'm going to go to my repo. It should be this one, Fun AI Projects. Go to, I'll provide this link in a second. And it's this one, app KNN. Yeah, so I'm going to add this link. So there you go. So the GitHub is this one. This has all the files. You'll have to create these files or modify these files, create your own repo, obviously. When you deploy it with Pages, you'll have a URL and it will look something like that. You see that? And then your machine learning thing will work. And then this third example here is just for PyScript. So I'm actually going to do this. PyScript. So it's a little bit more, because the other examples are actually mostly Onyx, which is not something we're going to cover today. And there you go. It looks a little bit better, right? So everything you need is here. If you notice, there's a few things in common between the GitHub and the Pages, right? So when this is free, by the way, as I said, you're only limited to 25 megs. If you haven't done so already, obviously that means go ahead and create your own GitHub, right? Get a GitHub account, create a repo. So you can see in my account, I have my GitHub here, and then I created this repo Fun AI projects. And then in there, I just create all the folders that I want. When I deploy and I need to access the URL, you can see that the URL is essentially youruser.github.io and then / the name of the repo. Do you see that? And then after that, it just follows basically the directory structure. Got it? Does that make sense? So you do your development on here, deploy with Pages, and then you click on the URLs here that open the application. And this one, PyScript here, is just a ton of examples of how to do things. All right. So let's take a look now at, now this example I provided, of course, is for KNN, right? So it kind of shows you how I deployed the KNN algorithm from last week, right? But you need to modify this code for your Perceptron problem, right? So I'm going to click on this one here, and you can see here that there. So this is essentially the website. So you would create an HTML website, and nothing here changes. It's just your basic text boxes as you would do them, and okay. Oh, yeah, that's right. Sorry. Right. Okay. Got it. The index page is index 2. So I will change that, not index 1. All right, so let me go back. So what I mean by this is if you look in the repo, right? This is the repo. I had index 1, and this was the old PyScript. And instead of deleting the file, what I did is I just copied it and did index 2. So you should use index 2. Okay? Does that make sense? It's the updated to the new PyScript. All right, so to fix that, I'm just going to go here. I'm going to go here and just change this to index 2. I forgot to. Got it? So, and then, so this is just a GitHub folder, so that should be fine. So now, hopefully it'll work. All right, so click on the URL, index 2. All right, you can see there are 2 buttons there. Waiting for something to appear. Oh, there it is. Okay. And then just a little slow. Okay, perfect. It works. All right, so this shows me that it works. As you can see, it's not very sophisticated or fancy. I have 1, 2, 3, 4 text boxes. What data set is this? This is the iris data set. So in the iris data set, it's a classification problem, right? You have 4 measurements of a plant, petal length, petal width, sepal length, sepal width. Those are the 4 measurements you see here. right? You insert those values into the text box, and then when you press generate, essentially KNN classifies that as either Setosa, Virginica, or versicolor. That was the example we did, right? For KNN, we use Iris. So it's essentially this, but deployed to the web. How do I know that it works? This is why I provided this here. And I notice I left two buttons in here. I think both of them work, but I'm using this one. Yes, go ahead. Is a what? The what? Yeah, all videos are on the on YouTube. Yeah, it should be there. Just look KNN in NumPy from scratch, something like that. Yeah, all videos are loaded. All right, so as I was saying, I provided this here so that we can test it. So these are just examples in the test set of these are the 4 values, this is the class. These are the 4 values, this is the class. So then that way we know if the model's working. For instance, if I grab, let's say I'm going to grab this one, right? Yeah. So that the values are 7.2, and I can maybe make it a little bit bigger. 7.2, 3.2, 6, 1.8. So the predicted class should be 2. Do you guys see that? So this is just to show you that it works. So I'm going to go ahead here. 7.2. 3.2. 6. 1.8. All right, so if that works, my class should be a 2, which is just this value here, okay? So I'm going to click generate, and you can see it is, in fact, a 2. Got it? That's it. So this is essentially you take an algorithm such as KNN, and you just implement it. Most of the Python code is the same. What's going to change is you put it within the HTML code, and you need sometimes to reference elements. So you guys remember in HTML, you learned something called the document object model, right? DOM. So here we have something called PyDOM, and essentially it's the same thing, but Python grabs it, and then you just reference the elements that you need, okay? So now I'm going to go over, so I've shown you this. Now I'm going to go over to the repo, and I'm going to show you the basic ideas of how this works. So you really just need, remember, we're using index 2. In this case, I have the iris data here. And I have this thing called PyScript.toml. So this file is where you put in the libraries that you're going to need. You need to like include them here and then in Python. So for instance, when I click on this, you can see packages that I'm using are pandas, matplotlib, and numpy. So essentially, you can probably just use this as is when you do your own code. And then we go back to the app. And then here, we're going to take a look at index.2. So this is all the code. Some people like to have the Python code in a separate file and just a .py file and then kind of bring it in as source. You can do that. Similar to the concept that you do in JavaScript, right? When JavaScript, you have script and then you bring in the source. But here, to make it even easier, I just hard-coded everything into the HTML. So quickly, as you can see, this is Python code, right? And the trick is you wrap the Python code with these tags. So you use a tag called script, and you specify the type as py, and then as the config, you provide that PyScript.toml file that I just mentioned. And that's it. That's literally it, right? So everything here is essentially the KNN code as we did in class. And then there's a few commands in here of how to grab values from text boxes and then how to write to something like a div tag or something like that in HTML. But everything else is happening in Python. So let's read it line by line, just so that you see. So when you do your homework, just use this. Like start here, add your perceptron in there, but it's a little bit different, right? So you're doing like an image, you're gonna have switches of a T or an L, and then you want it to classify it as -1 or +1. You guys see that? So that's essentially what the assignment is. Keep it simple. if you're going to learn the weights, as we did in the example on Monday, you do that in Python. You do that in Anaconda. Once you have the set of weights, then you can plug them into your model here. Got it? Which is actually how it happens, right? If you think of ChatGPT, they're not training ChatGPT in real time. You're using ChatGPT right now, and you're using the inference model of ChatGPT, right? And then overnight, they'll take that model and train it, update it, whatever it is, and then roll it out to the inference engine. So it's the same idea. All right, so let's look at the code very, line by line, and you guys can ask questions. So HTML tag, the head tag, you can just leave this as is. This is the important thing to notice here is this line here, script, basically is the PyScript.net and the core.js. This is what brings in all the JavaScript code for PyScript, essentially, your libraries, if you want to think of them that way. And then also you have a link for the CSS from PyScript. That's it. You just add that like you would JavaScript before, but now for PyScript, and then you can make it work. Then in the body, as you can see, I just have some div tags, some tables. I have this table here, which is where I have my inputs. You can see. So I have input is exactly how you do it in HTML. But what's important is the name, right? The ID, because you're going to retrieve those text boxes so you have the actual correct values. Okay? And then notice over here, I have the button, just a simple button, but you have to use this little flag here called PyClick, right, to tell it that it's going to be for the PyScript tags. Okay? And then this is just the name of the function inside of your Python script. Any questions there? All right. Then I added these divs. I added this one, test output, because this is where I want to write out some data. And I also added this one, MPL, where I show the results, essentially. So these are my placeholders for results as div tags. And then here comes the magic, basically. You open your inside, so you have the body, right? So here we are in the body of the HTML. And then I just created a section in PyScript here. And then I added the PyScript tags. And now I just start adding all the Python code in there. So you can see NumPy pandas, matplotlib. This is native to PyScript. It's Pyodine. You can use PyScript and PyWeb. This one, PyWeb, from import PyWeb, import PyDome. This is what allows you to interact with the document object model of your website, the HTML. So this is how you grab the input and the label and the div and so on. That's it. If you notice, this is just a Euclidean distance function that we covered in KNN. We've already discussed that in a video in the class, and you can check out the video. This is the entire algorithm of KNN. We already covered this. You guys saw that. And then here, for this example, I'm grabbing the data from a CSV file. As you can, oops. All right, great. So I'm grabbing, I just put the CSV data in my own GitHub, and then I just have to put in the full URL and I can retrieve it. So it's an easy way to get the data for training in particular, right? So you just use open URL, give it the URL, and then notice that you're feeding that into pandas. Very easy. And then after that, I did the whole replace Satosa with numbers, because remember that doesn't, we did that in the lecture also. We can't use the words. And then I convert the pandas into NumPy, all of it on the web browser. No problem. I do the shuffling, slice the data into XTrain. So here, that's one thing I didn't do with sklearn. I just did it here manually. Look at the data. So I wanted to just view the data. And so here comes the first important thing that's new. This. So here I have grabbed notice I have a NumPy array here, right? So I have NumPy data native to Python, and I converted it. So I did array to string. So I essentially took that NumPy array and converted it into a string object. And then that becomes string NumPy. I also did this to make sure that it's a string. And then remember that in Python, 2 pound signs means a comment. So that's not code that's running, but this is the actual code, right? So this is how you interact between Python and HTML. So in this case, what I want to do is I want to display the data. So what I do is PyDome. Then notice the syntax. You say div, because it's a div, pound sign, and then test output, which is the name of that div, the ID. Got it? So a little bit, if you're familiar with jQuery and things like that, a little bit like that. Any questions about that? So you say div, pound sign, the name of the div. Then essentially I grabbed it and then so I grab the object and then I just say .html and then I'm just assigning to it the text. Do you guys see that? That's it. That's the magic. If you want to learn more about that, go ahead and check out the PyScript examples. There's many examples in there. So if you're curious and want to make your homework more sophisticated. But this essentially gets you there. So this is how you write to the website. Obviously, you want to read from the website because in the website, you're adding the values, right? So the 4 features. So that's this function here. It's a Python function. But notice, so we do the same. So PyDome, and in this case, you don't have to provide also that it's a input tag. I just said pound sign and notice test input 1, 2, 3, and 4. So by ID, I'm able to retrieve the 4 inputs, and then this 0 is necessary, and then to specify that you want that first item, and then dot value. Do you guys see that? Dot value, and that gives me whatever I entered into those text boxes assigned into variables C1, C2, C3, C4 in Python. Got it? Yes, sir, please. Right, but you can be, instead of inputs, I would say do like switches or something. And your values are also just ones, right? 0 or a 1, for instance. But yeah, you can play with it. I mean, the Perceptron will allow other inputs, not just zeros and ones or -1 and 1, but I'm just saying play with it. Try to mimic that device because that's really what I want you guys to do. It's almost like I can't ask you to build it in hardware, but I can maybe ask you to build it in software as a website. And at the end of the day, what you care about is the logic, right? How does the Perceptron work? So I think you can capture with this. Got it? Did I answer your question? Yeah. Yeah, exactly. And if you want to also like print out that table so you see it's actually a T or an L, that might be a good idea. Got it? All right. So this allows you to grab the values into C1. After that, they're just Python. Notice I put them in a list. I do all the conversions that we talked about from list to NumPy array. You can change it to pandas and so on. This is just Python. And then finally, the last part, as you can see, and if you notice, this just closes out that PyScript tag. Very easy, right? So the last part here, just because notice that's the closing HTML. The last part is just my gen function. So that's when you press that button. If you notice, there was a PyClick event handler, and then that calls this function over here. Notice that you plug in the word event, right? And yeah, that's it. I mean, you invoke, get the inputs, you call the predict function, you do all of this as Python. Then you start converting it into text, and then you have, once again, the last part. What do? I invoke PyDome. I say that I want a div tag, pound sign, and then the ID is mpl.html, and I provide the result. That's it. You should be able to do that homework with this. The only thing is your code is not going to be KNN, but it's going to be the Perceptron. and you're trying to replicate that device as much as possible. I think, that's it. Any questions about PyScript or the homework? All right, so I've provided all these links. That's kind of the lecture related to that. So I will kind of, in conclusion, so we've seen this works. If you want to reload it, you just refresh it as a normal website. There's a little bit of a delay as it's loading the data set here. So that appears. Oh, there it is. And then I just wanted to predict on these. I provided some default values. So there you go. So the button. All right. So kind of in conclusion then, let's go over here. So the Perceptron is the lecture for this week. And then this is your homework assignment. I'm going to give you enough time for this one. So we're going to say 3 weeks for this one. Okay. But just do a good job. I'm looking forward to seeing it. All right. So links, click on it. All right. So this link definitely we want to change. So we're going to change it to here. All right. So I'm going to control copy. Go back here. I'm going to modify this link. This one. All right, so now it'll take you to the actual homework. This is the description of it. So I'll modify this. Change this to Perceptron. Using the Perceptron. There you go. And PyScript, develop a Perceptron device. I think this was called the Mark I, but I'm not sure. So develop a Perceptron device similar to the image provided. Okay, your goal is to not generate, but classify, right? Classify images of, let's say, L's and T's, although it can be something else. As discussed in class, right? So if you remember, this is the example I gave you, right? So you need to have examples of L's, examples of T's, train the model with that. Then when you give it a new L or a new T, it should say L, T, L, T. Does that make sense, guys? Do you understand? Yeah? Any questions about any of it? All right, great. So yeah, so that's the homework. So using the Perceptron algorithm, I should say, and PyScript, develop a Perceptron device similar to the image provided. Your goal is to classify images of L's and T's as discussed in class. You need to annotate your own data. You may need to do that, right? So you need to create examples of L's, examples of T's, right? And you need to like stretch that into a vector. You need to deploy to the web via GitHub and PyScript. You can use the code in the links I provided. Yep. Is that clear enough, guys, or do you want me to add something else to this? I kind of want you guys to demo this at some point. We'll do some quick demos of it. Yeah. Yeah, it is individual. This is a homework, not a project. It's actually, I think this one is easier than last year's homework, the KNN. I thought the KNN was a bit harder. So this one's easy. And maybe it seems challenging, but once you get to it, you'll see that. And it's pretty important because this is the simplest neural network. And my goal is really for you to really understand almost physically what a neural network is. And this is a way to do it so that everything else makes sense to you. The next 5 weeks of neural networks make sense to you. Okay, so any help that you need, just let me know. But I think it should be fun. All right, so I'm going to click save there. So I've changed the name and everything. Let me change it in the folder also. It should say Perceptron mini project. Perceptron. I'll say lab because it's not really. It's still worth the same as any normal lab. Perceptron lab homework. Okay, got it, guys. And I'm going to update it. And that should be it. Unless you guys have any questions. That's the homework. No questions? Everyone good? Yeah, go ahead, please. Yeah, 3 weeks, definitely. Oh, yeah, I have it. Week 8, somewhere like week 8. You want me to set I can create the link, no problem. I mean, I want you guys to maybe like demo these really quickly, so it'll be on a Wednesday that you'll demo it and just show what you did. All right, so let's do new assignment here. Homework, Perceptron, and PyScript. Okay. So today is the 5th, so the 12th, the 9th, the 26th, right? Yeah. So the 26th, 10 p.m. So on that day, it'd be nice if you demo. Okay. Just real quick, what you did, show that it works. Kind of like what I did today. See, I can do this and it predicts something. All right, so it's going to start showing now. And I'll leave it open until that Saturday, just in case. Complete the Perceptron and PyScript homework as discussed class. And I'll provide the link for it again. Just this one. Web Perceptron. So what I like about this approach is that if there's any like students find a solution or they find a thing and I can just continue to add links and maybe there's some issue that's going on, I'll add a little note here. So you guys should always check this page. If there's any problems that I'm seeing several students having, I will address them here and you can just double check, okay? So yeah, should be so that's it. Oh, yes, please go ahead. Exam 1 is week 6 in 2 weeks. So the first exam will cover, NumPy, tensor operations, the machine learning pipeline, KNN, the perceptron, and next week we're probably going to cover Hopfield network. So it'll cover up to that. Yes, sir. Yeah, so the exam will probably have 10 questions. Some of them could be essay type questions. Some of them could be write some simple code. So usually less than 20 lines of code. And I'm looking for understanding, not perfection, but I will ask you to write it in Python. So I might ask you like, what is this line in KNN doing? and explain that. Or I may ask you, can you write the code for the KNN? What is the inference function and the perceptron, things like that? Yes.
So
It's closed notes, but you're allowed a cheat sheet. So you can have like an 8.5 page. You can write whatever you want. So the homework, understand the algorithms, essentially. That's what I would say. Understand the algorithms and how they work.
that be just and definitely
Perceptron, also the machine learning pipeline, understanding what that is, all those steps, dealing with the data. Well, I mean, technically it's everything we've covered in class, right? So if I go over here, there's matrix and tensor operations, understanding some of those key operations. The machine learning pipeline, why these steps are important that I mentioned in class, right? All of these. Problem definitions, remember that? I can give you a word problem and ask you to identify X and Y, remember that? So there's that. Then Weka and how that works, that we implemented the whole pipeline there. I could give you some Weka output and say which one's the best and why. Remember, you're doing a homework on this, correct? Yeah. So, so that that once again ties into what is feature ranking. I'm not asking you for the algorithm for feature ranking, but you can tell me what it does, right? KNN, of course, the KNN algorithm and how that works, in the code. What is the Euclidean distance? The perceptron, which is the thing that we started discussing this week, right? In neural networks, pretty fundamental. And then, as I said, next, and anything we cover next week, which we'll probably cover one more algorithm next week. Okay, and this whole sequence for the next, let's say, 6 weeks is neural networks. So it's all building. So make sure you understand one thing because it builds. Question? Any additional questions? Yeah, so definitely study and create your cheat sheet, for the exam. Anything else? All right. So not hearing any other questions. So we are, so we're good with the homework, right? Everyone gets it. And like I said, it's not so much about the web stuff, but it's really about understanding, like if you build it physically, right? And and when you build something with a website, it's almost like you're building it physically so that you understand all the moving parts that are going on in it. Okay. Don't do the training on the website. Do that in Anaconda. Then when you get the weights, load them up into the website, basically. And so that will give you a lot of insight. Yeah.
So essentially on our website, we're gonna have 16 different switches. And a certain combination, one's T, one's gonna be L. Basically our output should either be 0 or 1.
Yep.
Depending.
Exactly. But you need to modify it in real time, right? So that's kind of like if you come here, I have the device, right? So, and you're demoing this, you would flip switches, and then this changes to an L, so that should move and say it's an L. Then you flip the switches, becomes a T, maybe it's a T that's centered here, that moves one step there, and it moves to the other side. The thing is, if it's an L, it's always like this, and if it's a T, it's always like that. So, which indicates class 0, class 1, or class +1, -1. If you put in a T that's supposed to be like this, and it does this, and I see a lot of that, then it's just randomly doing it, and you didn't do the task then. So it's got to be accurate, which according to the Anaconda Jupyter notebook, we're able to get good accuracy on that, on a problem like that.
so
Yeah.
like actually.
Drop downs. It's not going to be super fast. I mean, obviously you could, I mean, for somebody that has really good JavaScript skills, they could do a lot of really nice things, but for you can just do a drop. I mean, it literally could be an input, but the problem is you'll have typos. So it's better if you just do like a drop down and it's a 0 or a 1. Do you understand?
Oh, I see.
Do you understand what I mean? A drop down is a text box.
Drop down.
Yeah, you could
Okay.
do. That's easy. So because that way it's always 0 or a 1. If you don't even want to do that, inputs, but then what if you type an A in there instead? You have to do error handling. So, but yeah, the whole thing is 16, as you said, right? Drop downs, 0 or 1. Every time you do that, it'd be nice if we can see, maybe not in color, but in some way that it is a T or an L or whatever it is. And then obviously the knobs is something that you wouldn't do here, right? You would have the weights already. I mean, it would be really great if you also could show that you play with the knobs and it changes, but I'm not asking for that. That's how this device works, right? But you would load the weights, and then the essential thing is this does need to move correctly, because that's what it does. Yeah, sure. I mean, of what? Well, that's what I gave you the code for, right? So the code that I gave you is the Perceptron. So this is the code, right? We did this in class on Monday. So this data, right? This is the Y's. Did I print the X's? I think I did it in the Jupyter that I did in class. But this is your data. That's the L's and the T's. And the Y is whether it's a 0 or a 1. That's the same thing. And so once you train it, you learn this. These weights and biases are this. And so this is just the result of taking these weights, some new data, and doing a prediction, which is predict, which is this function here. So it's all there. Like, I think you're not really seeing that this is actually very easy, right? So all you have to do is you do everything here in the Jupyter notebook. Then when you do it here, you just need to create a vector that would fit into the function and predict the value. Do you see that? So even this may be, in fact, the only thing that needs to be in the HTML code. Do you see that? Because if you think about it, X test is what? The image. Do you guys see that? So as long as you get from the text boxes that vector, right, it fits in here. The weights and the biases have already been trained in the Anaconda notebook. And then this value that comes out here, Y-pred, is what changes this needle to be right or left. Do you guys understand? That's the whole point of this, right? To like link up that code to this machine and understand what's going on.
So,
These text boxes here?
Yeah.
Yeah, so you would have 16 drop downs, you grab them, right? And those values then wrap them in a list of 16 values, make that into a NumPy array. That's it. So okay, so let's take a look at what I had here, right? So if you go to this example in the GitHub, index 2. See, this function is exactly the function that gets the dropdowns, right? You select the dropdowns in the HTML, C1 through C16. You grab them. Whatever that value is, you'll have, the only difference is instead of 4, you have 16 variables. What did I do with those? I put them in a list, a Python list in Python. And then I converted it into a NumPy array. Do you see that? So once you do this, you essentially have xtest in Python. Then you just perform this multiplication here between xtest and the weights and the biases. Where did we get these weights and biases? From the Anaconda, because I did this on Monday, literally. And I even gave you a function where I extract weights and biases as their own variable. So these variables, you have to train it offline, right? You have to train it offline, and then you just hard code them if you want as variables in there. The same way that I did this. So instead of reading them, just hard code them. Create a list of weights and biases, convert it to NumPy, do the matrix multiplication. That's it. You're done. Then you have the value that indicates, that needle. So it's this one or that one. The key, though, that I'm going to ask you is, okay, go in there and make an L. Make another L. Now make a T. Now make an L. Make an L. Make a T. If you get that right, it's working correctly. You see what I'm saying? That's it. So deploying it to the web is, I think, very straightforward because you only need one simple function. What might be difficult, I assume, is that you have to change this data, right? Because when I did this data here, I created vectors of size 2, right? And yours is 16, yeah? So you have to create those manually, but it's what, 50 samples? I mean, it's not going to take you that long. And also they're this repetitive, right? You can only have actually 2 types of L's, 2 types of T's. Remember, it's a 2-dimensional, but you stretch it into a vector, right? You guys get that? That grid becomes a vector. So it's 4 by 4, it's 16. You really just have 4 variants, I think, in fact. Right? T, another T, L, another L. T's have a 1, L's have a 0. You create that.
So
yeah.
Would we have to create a CSV file?
In my example in PyScript, I have a CSV. Yeah. So then you could just change it there if you'd like.
Yeah,
Right. I did random, right? Exactly. So to train, actually, I get your question now. It's a good question. So for training, you're right. You would do it here, kind of manually, I would say, just to make sure it's correct. I'm sure you can write some code, but yeah, that's essentially what it is. So you just that's why we're keeping it at 4 by 4, right? So you can draw a T, which fields have a 0, which fields have a 1 in there, and then just make that into a vector. Essentially, it should be 4 types of vector, 2 for T, 2 for L. And then just create enough of that, so at least 50 by hand associated with the right label. If you understand this, that's how everything is going forward. It just gets more complex, but it's the exact same pipeline. You see that? Any other question? Yeah, go ahead. Yeah. So it's PyScript. Deploy to the web. Oh, you mean how to host it?
Yeah.
That's a good question. So yeah, that actually, you're right. So to do that, you go to GitHub, create an account on GitHub, create a repo in there. So what I did, so I'm going to use the example actually where I have this. So once I created my account, I created this repo, Fun AI Projects. And then I created this folder here. And then this one, I mean, it doesn't matter where it is after that. And this one. And I just dump my files in there, like how you would do in any website HTML, CSS, JavaScript files. So they're all in here. Then you go to settings, pages. Everyone has this for free. And then all you have to do is here, you say deploy from branch. Make sure that's checked and that this says main, and that's it. After that, it'll take a little bit, like a couple of minutes, and it'll give you the URL, and you have, as long as it's index.html file, it'll work as a HTTP. That's all you need. Make sense? Make sense? So I'm giving you 3 weeks for this. Obviously, if you have issues, let me know. But yeah, it should be, remember, you're just doing the inference on the website, do the training on the on Anaconda, basically. And the hard part, which in all machine learning, the hard part will always be the data. The algorithms, as you see, you just reuse them, tweak them a little, change, but dealing with the data is always going to be a challenge, essentially. Any other questions? All right, great. So let me know if you have questions. If you want to, I encourage you to start working on this. And when you hit a roadblock, come see me, right? And we can, complete this assignment. All right, so what I'm going to do now is that's the homework. So I'm going to shift gears back to the Anaconda example. I'm going to go, now that you have some questions, possibly, I'm going to go back to it. We're going to review it one more time, okay? So share. I'm going to go to all, Anaconda 3, Anaconda prompt. dir cd system. This is ITS 3620 2020. All right, so we were working on in-class Perceptron, right? So that's where I'm going to pick up. I'm going to do the Conda environment list. Conda activate. I think we're using 3.7. So pi. Pi 37 2025 ITS 360. All right. So Jupyter. Both. Okay, so this is our Perceptron. And here we are, right? So let's go through it again, right? We're going to repeat kind of how it works. I'm going to clear the kernel. or restart it, I should say. I'll kind of go over the parts first. So we have run the Perceptron, run the libraries, NumPy, sklearn, matplotlib. The perceptron and all of neural networks are essentially that multiplication between the inputs x and the weights plus a bias. And that equation is very consistent. It just gets a little bit more complicated. Usually the result of that goes through something else called the activation function. And that's essentially the game. So in this case, the output of that matrix multiplication, x and w, is z, and that goes into this very simple activation function. Essentially, if it's greater than 0, it converts everything to a 1. If it's less than 0, it converts everything to a 0. Okay? So you can see how I'm testing this here. So I do activation minus 0.3, 0. I do minus 7, 0. Does that make sense? These are activation functions. Whatever comes out from that multiplication, you can modify it. I do the same with this one. If it's greater than 0.7, it's a 1. You know, it could be 1.7. It's a 1. Okay? So this part, the fit part, if you notice, this is the training, which will return the weights and the biases, right? So the thing, you know, we have an x, an input, multiplied times some set of values called weights, plus a bias that gives the result. So this is the result of training on the training data, okay? So we went over this algorithm on Monday, but I'll repeat it today. But essentially right now, this is the fit function. Once you have that defined, then we go look at the data. So here I created a random set of data. Okay. For your example, for the perceptron, this n features would be 16 instead of 2 because it's 4 by 4. Right now, you have images that are 4 by 4, but you have no way of feeding that with your current knowledge. You can't feed a two-dimensional array into a neural network, not yet. So the only solution that you have is to feed it vectors, right? So what we do is if we have something that is 4 by 4, is we take 4, then 4, then 4, and 4. So we concatenate it to be a vector of 16. So that's this over here. So if I do this, now this, of course, the problem why you can't use this in your example, in your Perceptron homework, is that this is random data. But you actually want to have some logic like having T's and L's, right? So you have to learn what that looks like. Just draw a little grid, put zeros, ones until it looks like a T, right? And then stretch it. Does that make sense? And you should only have about 4 of those values. Different variants of that, because we don't have that much flexibility. All right, so but here, let's say I do 16, right? So then if you look now, it's 150 by 16. Okay, if I print out just the first one, let's say x 0, first row, that's it, some values. Obviously, yours will probably just have zeros and ones or something like that. If it was pixels, it could have, you know, grayscale values.
So
Go ahead.
when we go to make our P's and O's, we need to put a good amount.
Yeah, that's a good question, right? So I would say, I think I said 50. 50 is a good amount, I think. Just 25 of one, 25 of the other one. Hopefully it'll be enough. I mean, you're just trying to replicate that machine essentially, right? So yeah. So in the original Perceptron, actually, I think it was 40 by 40, and they actually had a camera. So the camera would take a picture of whatever, and then you could feed that in and try to train it. So that, but this is a much simpler device. Yes, sir.
That'd be like the PDF
plot.
The CSV file.
The zero.
That's right. So yeah, so exactly. So that's let me switch to the whiteboard since you have a question with that. It doesn't have to be T's and L's, right? That's just what the graphs had. But so the idea is you have an image. Oh, sorry. You have an image. So it's got 1, 2, that's 4, right? And then 1, that's 4. That's one image. And this is going to be a T. And we're going to say T is -1 for whatever reason. And L is +1 for whatever reason. Or it could also be 0 and 1, either one, right? You choose. So if it's a T, then this is, right? Do you guys understand? So then spaghettify this, which means what? You grab the first row. So now you're going to switch it into a vector notation because this is all that will fit into the neural networks currently. So you'll do 1, 1, 1, 0, right? And then you concatenate the next row. What is it? 0, 1, 0, 0. Do you see that? This is machine learning, and this is it. This, I'm sorry, but this is it. This is machine learning. So, and then, so now you do this. So the next one, right? 0, 1, 0, 0. And then the last one, 0, 1, 0, 0. There you go. You have a sample. That's your X. That's sample 1. If you remember of the X and Y, this is size 16. That's why that was so important. And then the label for this one, since it's a T, let's say 0. Now you do the second example, and it's going to be maybe another T that looks exactly like that. So this row should be the same with a 0. Then you do an L. Right? So that's the grid. So this is a key thing. All your images need to be the same size. If some of them are 4x4 and others are 5x5, it doesn't work. It just doesn't work, right? It has to be like this. When you have images on the web that are all different, you have to make them all the same size. Even if you lose aspect ratio or you crop or whatever, but otherwise it will not work. So I'm going to switch the color here to green. So now we're going to do an L. I don't know. Let's say 1, 1, 1, 1, 1, 1. Just like that, right? And so the other ones are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So we spaghettify this. We know the label is going to be, it's an L, so it's a 1. See that? And so grab the first row. So what is it going to be? So it's 1, 0, 0, 0. Next one. What is it? 1, 0, 0, 0. What's the next one? 1, 0, 0, 0. What's the last one? 1, 1, 1, 0. Essentially, you start to create your X. This is a 2x16 at this point. Do you guys see that? Now add 48 more. because you will have other variants. What's the other variant of a T? One shifted, yeah. So in my case, 1 1 1 1 1 1 0 0 0 0 0 0 0 0 0 0. And you just repeat the spaghettifying process yet again. You keep doing this in a CSV. I mean, this is just 1 comma 0 comma 0 comma 0 comma 1 all the way until the end of that row, and then the next one. Does that make sense? That's it. That's your data right there. But the thing is, you create this to train, right? Once you train, you get that WN bias. Those values go on your website when you make that matrix multiplication, and you will only be doing inference over there. Yes, sir. Each one of these is a row in the CSV. Each one of what, I guess? Each one of what?
You said the one.
This, so you want me to draw the CSV? Give me a second. To do that, I will erase a little bit here. So let's say we've done these two images, right? Two images. So now the CSV. To erase this. Okay, so I'm going to do the CSV here. All right, so CSV. You need to be consistent. So I'm going to do the first one. Hopefully I can get all 16 in here. So 1 comma 1 comma 1 comma 0 comma 0 comma 1 comma 0 comma 0. I'm going to skip this one, okay, because I'm going to run out dot 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 0 1 0 0, and then the last one is the label, which is 0. You see that? Make sense? Did I answer your question? Then the next one, what is the next one? The next row, this green one, 1 0 0 0 1 0 0 0. I'm going to skip dot dot dot. The last one, 1 comma 1 comma 1 comma 0. And then the label is what? 1. So when you do this, when you read the CSV, as I did, slice it, right? So you grab the first 16 as X, the last one as the labels, and you have the exact same thing. Got it? Any other questions? Yeah. You can put them like that. You can create this CSV with about 50 rows. So, I mean, the easiest thing is just to draw them. They're all going to be essentially, this is 2 T's, right? You don't have any other combinations of T's. So you can just repeat that, but it's always the same label. You see what I'm saying? So what is your question?
For of your vectors or your vectorized data to the CSV would work.
This is the CSV, right?
Right.
So in the KN, so do you mean read the CSV into a NumPy array?
I mean, like, take the data. Well, aren't we taking the data from that NumPy array and putting it into the CSV? Or is it the other way around?
It's the other way around. So CSV is just data, and so that you can store it in a file. Then you load it into a NumPy array, which is the thing that you have in memory to do operations on.
Yeah.
So if we look at the Jupyter Notebook here, for instance, this is your data, X shape, right? So you can, I'm just showing one row of it. So I could show from 0 to 2, comma, all. So that's essentially 2 rows that are of size 16, but that's already in NumPy. If you have it in the CSV, you just read this into X basically.
Right.
So that's the idea. Any other questions? Yeah. All right. So let's go back to so you had the question, right? So did that make sense? Yeah. Yeah. So that's how the data would work, okay? Let's see here. Yeah. So going back to this, your images are this, you convert them into vectors. So this is pretty straightforward. None of your images are ever going to be like this. I mean, real problems, as we start to look at real problems, images are going to be 28 by 28. The vectors are going to be 784. There's no way you can do that manually. You can do that here for this one time. And you just have 2 types of letters. But the process is always exactly the same, right? So taking an image. Now, the more complex thing, if you had color, is you would have 3 of these grids. So think about it. It would be 16 times 3 and so on. But you're not doing that for this one. All right. So it's 3:22. So let's go over the script here in class. The problem with this one being 16 is it looks like this. Let me make it 8. Just imagine the images are 8 instead. So now it's 8. And still it looks a little bit too big because the values, yeah, so let's do 4. Right, so now you can see every one of these is a row of size 8. Okay, and this is the data that you would store. So anyway, that's one of the challenging parts is you have to collect that. All right, so let's go back to the original way that we had this perceptron. Okay, I'm going to go back to the beginning here and run it again. Okay. So I'm going to hit run, got the libraries, got the activation function. Remember, it's the value comes in, it becomes a 0 or a 1. Okay, we did these examples here. You can see how that works. This is the whole algorithm of training. And whenever we're doing neural networks, this is going to continue to be this way. We're just going to be adding way more in here going on as we make the algorithms more complex. Once you fit you create that's the fitting function, which will return weights and biases. So keep track of that. Then here I create some random data, print a shape, which is 150 by 2. I have 150 samples. Each one has 2 columns. And the value, and these are 150 because every vector here has a label, essentially, right? Remember, the machine learning model is trying to learn, if I see this pattern, what label is it? If I see this pattern, what label is it? It's trying to correlate them, okay? So I'm going to hit run here. Those are 0s and 1s. And then I split my X and Y into X train X test and Y train Y test. And that's just so that I can have some samples. So I suggest that you guys do this for your model. Train, let's say if you do 50, train on like 30, and then test on 20 or, something like that. But this is key, right? So when you do this, this is where you get the weights and the biases, which if you look, and it's running, right? So it's going to take a second because it's iterating through it. So let's give it a minute. There we go. So if you have a vector of 2, you have 2 weights. So let me ask you now, for your images, you're going to have 4 by 4, which are 16. So how many weights are you going to have? You're going to have 16 weights because for every input, you have a weight. Just like for in the image, you have 1 pixel and a potentiometer, another pixel and a potentiometer, right? So that's the same thing. So here, for the example of 16, you'll have 16. This literally printed, loaded up on the website, make it into the weights vector. The bias, now let me ask you this question. How many biases are you going to have in your perceptron? You mean the other remember, it gives you weights and biases, right? So how many? So here, 16, because 16 x's, 16 features. You should know, and this is always like this. So now, how many biases are you going to have? Here we have 1.12. How many biases? So the question to ask is, what is this related to? Is this related to the inputs or the outputs? So the bias is related to the outputs. So how many outputs do you have? You have 1. Because this is controlled by 1 variable, 0 or a 1, right? Do you see what I'm saying? So that's what it's predicting because it goes into, this value goes into that activation function here, which only returns either a 0 or a 1, but there's only 1 value. You see that? Yeah, that can happen later, but right now we just have 1 neuron that gives us either a 0 or a 1, a binary value.
Okay, so it's less about like the possibilities of the output and more about what the output is.
Yeah, like so here you want to think of it in terms, it's a good question actually. You want to think of it in terms of neurons. So you have essentially 16 input neurons and 1 output neuron. And that output neuron needs to learn to predict. So these neurons can learn to predict whatever you want them to predict. Because they could predict a probability from 0 to 1, such as 0.75 probability, right? That's possible. But in this case, we're constraining it even further, like to the max, by saying only 2 binary, -1 or +1, or 0 or 1. But they're constrained to being a binary thing. So in this case, we only need 1 bias. Why do we need this bias? It's actually interesting. If you have x's and w's, the problem is, what if everything is zeros? Then 0 times 0 is 0, right? Whenever you have a 0 times something is 0. And so for that particular case, you want to have a value that in case everything is 0, it can still tell you something about the model. Like for instance, what if we have a 0 case where all the values are 0? Then everything would cancel out, but you have that little bias that actually has a little bit of knowledge of what to do with all those values. Do you see that? So that's kind of the intuition. And there's also a geometric intuition of it, but of the bias of a line in like in algebra and geometry. Okay, but that's kind of the idea. So the bias is it won't go away. We're going to continue looking at these biases in the future. We'll see that there are situations where we have more biases, but it's when we have a model that's, for instance, 16 neurons as input and 3 neurons as output. So each one of those output neurons is a bias. We'll need a bias. But in our case, our neural network has 16 and 1. So this is a good point to draw the neural networks. Why are these neural networks, right? So I'm talking about perceptrons here. And now I'm going to give you the following. So, so I'm saying this is a perceptron. And I'm trying to convince you that this is something called a neural network, although it's like the simplest neural network ever made. For my example, I had 150 by 2, correct? Because we had 2 columns, just for the initial code example. So what does that neural network look like? Well, the inputs are always 2. So then that's the neural network. That's a neural network. You see that? We have an input layer and an output layer. Now, your example of the images. You have images that are 4 by 4. You spaghettify them into vectors of 16. The input now is of what size? 1, 2, 3, 4, ... all the way to that. I'm not going to draw them all, but there's 16 in 4 by 4. That's the input. The output is still just 1, and it's fully connected. And what does that mean? It means this neuron here is X1. This neuron here is X2. This one is Y, and these are W1, W2, the potentiometers. You see that? So this can be expressed mathematically as X1 times W1 plus X2 times W2 plus what? A bias. And the bias is linked to this neuron here. Only one. You guys see that? So that is the essential representation of what I was doing, right? So that dot product thing that I'm doing, you know that operation that I'm doing in the code? This one here. This operation is exactly that. Why? Because that's why you learn NumPy representations of vectors. So what you need to understand is that we break this into all the weights together as a list almost, and all the x's together as a list. So if I go back to my example here, in the code, I have x as x1, x2, and I have w as w1, w2. So that's why I can do an operation np dot, which is the one that you saw there, where I just take x. Let's put a little mark in here so we can reference them. So x dot w plus the bias. That's exactly the same operation over here, right? So you see np dot xi weights plus bias. You can see I kind of wrote it down here, but essentially this operation np dot of x is like that, where x is x1, x2, w, and then essentially you can draw it out as the full equation of x1 times w1, x2 times w2 plus b. And again, now going back to the drawing or the hardware perceptron. So that would be in homework. So x's are these values, right? So this the first red dot, that's x1 times potentiometer 1. So x1 times w1. This one here, x2 out of 16 times w2 potentiometer 2. You see that? The values we need to learn, and so on. And I think someone had the question, what about this last potentiometer? We have 17. That's that bias because it also needs to have a value. So we multiply these times these to get this value here. And that's essentially what it is. And we just have to get used to the fact that whenever we're talking about the neural networks, we can graphically write them like this, or we can mathematically write them like this, or in code we can write it like this. But they're all the same thing. So this is input 2, output 1, input 16, output 1, and this is your homework case. So this is your first neural network, which is very basic, a perceptron with everything in it. Okay? Any questions? Yeah, go ahead, please. Yeah, you can just hard code it. So because going back to the code, I'm here in the fit function, I will do the training, right? I will do the training for it. And if you notice over here, I give it the data. Once I finish training, my example provides weights and biases here. And if you look, so these two, for the vectors of size 2, these are the weights and the bias. So essentially, you could just put them in the HTML. The only difference, of course, is your example is going to be 16. So you would have, I think this is where we were, a vector of 16 values here, and just make sure, obviously, that they correspond. So x1 goes with w1, x2 goes with w2, and all the way to 16. Because it's the same data. Yeah. Yeah. You have to create the data. So that's the challenge, right? You can't do this. There's no way. So instead, machine learning, you get a set of data and you train it through this function called fit. So you give it, let's say, 30 samples for training, run it through fit. At the end of training, magically, it gives you weights and biases. And that's what you use to predict going forward in the test set.
Dummy test. Just figure out what step these weights do. So then
not a dummy test. I would say this is called machine learning, right? So here you have algorithms that learn from data. So the neural network is like a memory device that is going to capture just the pattern that it cares about. It's going to discover that pattern, but it needs to look through the data that you provide.
Oh, I see.
Yeah, so another example I can give you is this. You could write a whole bunch of if statements, right? You could start doing if statements, blah, 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 blah. And maybe you would get an input and predict a value. But what's the problem with that? You have to be very smart and figure out all those if statements. That's a heuristic-based approach. But that's not the power of machine learning. The power of machine learning is you just dump data on the algorithm. The algorithm looks at the patterns, the classes, and it figures out the set of weights that it needs to do a correct prediction. It discovers it, basically. Hence the name, machine learning. The weights are applied in two ways. Train it in, you can test it here in the Jupyter as we did on Monday, but also you only need the weights in the website. So when you look at the website over here, when you build your website, essentially, you just need this function, as I was saying. So you give it the correct weights and biases, and it performs the operation on the test sample. So now you're going to have a set of test samples just to measure performance. Yeah.
And
training.
That
fitting is and training is the same thing. The function is just called fit. I gave the name fit, but learning is happening here in this algorithm.
and then I also
Well, what you're doing is you are doing this operation during training. So initially your weights are pretty bad. And so the result is bad, but it's learning from those outputs to improve them. By the end of training, hopefully you have a really good set of weights. That's the whole objective. And so then that equation does predict now. And that's it. But you want to build this application that given new test samples that it's going to predict correctly. So you're going to give it a new T or a new L, and it's going to say whether it's a T or an L. So that's it. So that's essentially the whole pipeline of machine learning. So this same approach is how you build more complex, multi-layer perceptrons, deep learning, CNNs, ChatGPT, which is a transformer, all of it. And the only difference is, as I've said, I think many times, whereas my weights here are only 2 plus the bias, 3 parameters, ChatGPT has 671 billion parameters. Do you guys see that? That's the difference. So the architectures become bigger and bigger and bigger, and you just have to learn more. But that's how neural networks work. Okay, so it's 3:41. We'll stop here. I'll load this Jupyter notebook so you can play with it. Okay, and then we still need to go over the derivation of the learning rule, this thing here, right? Because this is actually what figures out the weights. So we're going to do this on Monday. Okay. All right. So we'll stop here for today.